All right, so welcome back. Today in this video, we are going to be continuing our water resources and environmental engineering review for the Civil FE exam. Now, in this particular section, we're going to be covering groundwater, and I have some practice problems for you all. So let's go ahead and dive right in. All right, so number one, it says a groundwater well has a specific capacity of 15 gallons per minute per foot of drawdown and a pumping rate of 250 gallons per minute. Calculate the well drawdown. All right. So we are given what? We're given the specific capacity. And we're also given, and that specific capacity is 15 gallons per minute. We're also given a pumping rate, right? That pumping rate is basically a flow. And so a flow is just going to be, your gallons per minute, cubic feet per second. It's a flow. All right, so we're trying to find drawdown. Okay, so what are the formulas needed for this? I don't know. Let's just look up well drawdown. Well drawdown. All right, well drawdown. DW. Q is the flow. Okay. And then a DW is the well drawdown, and then equals the specific capacity. Are we given specific capacity? Yes. Are we given Q? Yes. So the only thing we're solving for is DW. So I can get this using this formula. All right. So I know that Q divided by dW is equal to specific capacity, right? But I'm solving for dW. So we need to convert this to say, not that dW is equal to, right, Q divided by the specific capacity. Okay. And so that's going to equal, what's my flow? My flow is 250 gallons per minute, all divided by my specific capacity, which is 15 gallons per minute per foot of drawdown. All right. And so when we cross out our units, left with feet. So this is going to equal 16.67 feet, or C. All right, let's look at number two. Number two says, calculate the drawdown in a well after 24 hours, continuous pumping at a rate of 15 liters per second. The specific capacity of the well is 0.0025 liters per second per meter of drawdown. Okay. So looks pretty similar. All right. So we got what information are we given? We're given time After 24 hours, we're given flow. Pumping rate of 15 liters per second. And then we're also given what other information are we given? Capacity. This specific capacity. All right, so what are we trying to find? We're trying to find the drawdown, the well drawdown. All right. So similar to the question before, we need to use Q divided by dW is equal to specific capacity, just this formula here. Okay. And then we want to convert it again. Convert this to the W is equal to Q over SC, our specific capacity. And then it's just plug and chug from there. So what is our Q? Q is 15 liters per second, just different units, but same process. Specific capacity of the well is 0.0025 liters per second per meter of drawdown. Okay, so those units are going to cancel these. And you're left with meters, right? So I get this is equal to 6,000 meters. Okay. That's the drawdown in a well. All right. Let's look at number 3. 3 says analyze a aquifer with the following data. Hydraulic conductivity is equal to 12 meters per minute, and the thickness of the aquifer is 2 feet. Determine the transmissivity. Okay. So we are given what information? Well, we're given the hydraulic conductivity. Hydraulic conductivity. And we're given the thickness of the aquifer, right? We need to find the transmissivity. I always feel like I'm gonna mispronounce that. All right. Okay, so let's look up transmissivity and let's see if we can use the thickness of the aquifer or the hydraulic conductivity to help us. Okay. Transmissivity, okay, is denoted by T, which is equal to K times B. Okay. What is K? Okay. Don't know what K is. Let's stay there. I think we were getting close. So K, is it denoted somewhere else up above? Okay. The coefficient of permeability or the hydraulic conductivity in feet per second. So what is our units? In meters per minute. So we might need to get that in feet per second. And then what is B? Right. B is the thickness of the confined aquifer, okay? And that's in feet. So we know that we're going to be using, let's use a different color. T is equal to K times B, where K is equal to 12 meters per minute, and we need to get this in feet per second. All right, that's what K, so this coefficient typically is in. So how do we get this in feet per second? We can do a unit conversion. All right. So how many meters are in a foot? Always use the handbook for that. Unit conversions. Anytime you have a question, typically you're going to be able to find it in this unit conversions section for how to get something in the units you need it for. So, all right, we need meters to feet. Okay. So 1 foot is going to be 0.3048 meters, or 1 meter is equal to 3.281 feet. It's the same thing. So I'm just going to say 1 meter is equal to, I'm going to use this one, 3.281 feet. Cool. And then we got our units in feet, but we need it in feet per second, right? That's what this is what K stated, right? We need it in feet per second. Okay. So to get this in feet per second, how many seconds are in a minute? Oh, we got 1 minute. We got 60 seconds. Okay. All right. So do we have our units to cancel to get it in feet per second? I think we do. When we multiply and divide this out, we get 0.6562 feet per second for our hydraulic conductivity and the units that we need it to be in. All right, so we got K. What is B? All right, I'm looking at the variables that I need, right, which are here. We got K. What is B? Well, I know that B is going to be the thickness of the aquifer, and we get that to be 2 feet. It's given. So now it's just a matter of plugging and chugging to get our transmissivity. Cool. So T is equal to K 0.06562, and I accidentally did too many zeros, so it's just going to be 0.6562, and then something on my screen. All right, times my B, which is 2 feet. But I want to make sure you know the unit, so I'm going to go back and do this, write it out. So this is feet per second times 2 feet. And so when we do that, we get approximately 1.3. What of our units? Well, foot times a foot, feet squared. All right. All divided by seconds. Our answer is A. All right. So that concludes the section for groundwater in the water resources and environmental engineering section of civil for your civil FE exam review. Next, we're going to look at water quality. I'll see you in the next video.